Hi, today we have something completely different. Every now and then someone will contact me with some product with a problem, and if it's similar to some of the things that we normally work on, and if it seems reasonable, I'll agree to go ahead and take it on just because sometimes it's something different and to try to help the customer out. So what we have today is we have an 8-note long tube Rittenhouse door chime, and this is a door chime model C8846R, and it was made probably somewhere around 1991, near as I can tell. The complaint with it was dead. It didn't work. Hadn't worked in a long time. They didn't remember how long, but they really wanted it to work again. And after a lot of questions, I found out that it was a fully electronic chime, not counting the solenoids, of course, those are mechanical, but it doesn't have a clock motor and contacts and all that. It's a fully electronic circuit board. And I figured, well, it probably isn't that much different than a NuTone fully electronic 8-note chime board. So I told the guy, yeah, I'll give it a go and see if we can get it figured out. Now, there's no service manuals, there's no wiring diagram, there's no technical information, there's nothing about any of this that I could find anywhere online, and I'm sure it existed at some time or another, but when you come right down to it, come on, it's one little board. It's really this. This over here is just where the wires are connected, so that doesn't really count. It's really all about this. When it came in and I had a chance to look at it, I was pleasantly surprised because it actually looked very familiar to me. Why did it look very familiar? Well, it did because it's pretty much the same as this. This is a NuTone 8-note long tube electronic chime board, and this could be cousins. They're very, very much the same. They're based around the same two integrated circuits, and fundamentally, they're just sort of dead ringers for each other. A little bit of difference here and there, but not a whole lot. So that brings up the question is, who stole whose design? Did NuTone come up with this one and then Rittenhouse borrowed from it? Or was it the other way around? Or did some cosmic force come into play and all of the stars aligned and two different engineering departments just happened to come up with almost identical chime control boards? We'll never really know because there's no one left to ask. So let's look at some of the similarities between the two different boards. This is the Rittenhouse board. This is the NuTone board down here. Obviously the NuTone board is bigger, and also the terminals where the wires are connected are way clearer to understand where you put the wires, but we'll get to that part at the end. So what do we have here? Well, we have a lot of basic similarities. You have two integrated circuits. One's a decade counter and one's a Schmidt trigger, and same two identical chips on both boards, absolutely identically the same models. You have a primary power supply filter capacitor here and here. You have one single transistor here and another one here. Well, there's other transistors, but they're for other purposes. This is primarily for voltage regulation on the board. There is a little Zener diode down here that's part of the voltage regulation circuit. There's one here and one over here. There's a switch here for 4 and 8 notes and another switch here for 4 and 8 notes. You've got 3 large high wattage resistors. These are 100 ohm 5 watts. These here are 50 ohms. I'm guessing they're more like 2 watts, something like that. Down here on the NuTone board, you've got 4 transistors. These are the driver transistors that drive the solenoids that make the plungers strike the tubes. And these are all what are called Darlington transistors. If you're not sure what that is, Google it. You have 2 diodes associated with each transistor. And down here on the Rittenhouse, where it's a little hard to see right down here, you have the exact same setup. Are they the same exact transistors? No, they're not, but they were made at different times, so these may have been the flavor of the day for Darlington transistors, and these may have been later on. This board is later than this one. This one is more like 2005 or so. So it is, for all intents and purposes, they're virtually identical. They could be kissing cousins because they use the same parts. The layouts are a little bit different, but that doesn't really count because the way it operates is exactly the same. So which one is better? Beats the heck out of me because I don't think it really makes that much difference. The NuTone one's a little easier to work on because it's a little bigger and you've got a little bit more room, but you know, other than that, it's not really that big of a deal. One of the things that I do like about the Rittenhouse board, better than the NuTone board, is that Down here, next to the solenoid driver transistors, we have 4 colored wires. There's a white wire, a blue wire, a red wire, and a green wire, and these wires each go to their own individual solenoids. And the way this is constructed, on the end of the little tiny hair-sized wire that's inside each colored sleeve, it's actually soldered onto a little socket pin that pushes down onto a pin that's soldered on the board. So if you needed to, you could easily just unplug them and they're free from the board. That's better to work on it because the little hair-sized wires, if you bend them around a lot, they tend to break off, and on the NuTone Chime boards that happens quite a lot, then you have to fix them. So that's a better design. The other thing about the Rittenhouse Chime, which is completely different than the NuTone Chime, is the different ways that you can actually power it. This is a close-up of what would be the terminal board for the Rittenhouse Chime, and as you can see here, you've got 4 screws across the top and 4 screws across the bottom. These 2 screws are just marked as terminal A and B. A is on the top, B is on the bottom. What are terminal A and B? Well, it took me a little bit of snooping around to try to figure out what those were, and that's basically where the transformer wires get connected. Why it doesn't just say transformer beats the heck out of me, but they chose not to. But this chime has a unique feature. If you look here, you have 3 screws here, you have front, rear, and side, and underneath it says use with 2 9-volt batteries, and then there's little arrows that go up to indicate that you use these 3 when you're powering it off 2 9-volt batteries. And down here you have also 3 screws, which are front, rear, and side, and it says use with 16-volt AC transformer. So you have 2 different ways you can power this. I have it powered up right now on a 16-volt transformer, but you can also power it from 2 9-volt batteries. And here you can see, taped underneath the old tape here, you have 2 9-volt battery snaps. So if you didn't have a 16-volt transformer for power or something like that, you could power it off 2 9-volt batteries. I think there's also a way you can set it up that if you don't have adequate wiring, maybe you're replacing an older 2-note doorbell and you don't have enough wiring right at the chime, I think you can wire it up for operation off of the 9-volt batteries and a transformer. I think there's different ways you can do it, but I couldn't find any sheets about how you do that, so I can't really speak to that with any authority. It's a more flexible chime. I assume they came up with that because they were interested in selling as many chimes as they could, and it just gave people more options. One of the things I don't like about this chime is I don't like these little plastic standoffs that the boards snap onto. There's 3 of them to hold the large board in place and 1 to hold the small board, and you have to like compress these with a nut driver to squeeze the ears in so you can pull the board off. And when I was doing that, these 2 boards originally were kind of joined together here, and there is a row of perforations here, so they could be snapped in half. That's how circuit boards are made lots of the time. 1 panel, lots of boards that you snap apart. And I would assume they did this because maybe in some models, maybe the board was mounted at a 90-degree angle or was mounted further away, or it gave them more flexibility. And the little board is tied to the big board with this flex cable that has wires in it, and it lets you move it around. So we're going to snap this back down here. Try not to get the wires all jumbled up. And see, it's easy to assemble because you just push it down and it snaps in place, but when you have to take it apart, it's a total pain in the neck. And then we'll go ahead and move our wires out of the way, and we'll snap the little board down. Now, since the little board is only held in with 1, and we don't want it flopping around like this, I'm going to have to find some double-sided foam adhesive pads to put under here to give it some support, because this is where the customer is going to be connecting his wires, and we don't want it doing this. It's unfortunate that it broke, but it's old, and it didn't really break. It really just sort of came apart, because that's what happens sometimes. Okay, so I've got it set up, so let's give it a go here. It is a 3-door chime, so you have front, rear, and side. The front door is either 4 or 8 notes. The rear door is a single note, and the side door is a different single note. So we'll go ahead and ring the side door first, and get a single note on this plunger here, and then we'll do the rear door, which should be a different single note. This one here, And now we'll go ahead and do the 8 notes for the front. And we'll switch the little switch here to 4 notes to make sure that works correctly. And it does. There is a little adjustment here. It's a adjustment pot. It's the quote volume control for it, and it's basically a rheostat. It's an adjustable resistor, so you can turn it to a lower setting, and it will supply less voltage to the plungers, and they don't strike nearly as hard. And that's it, the 4 notes. So it seems to work well. One of the things that's interesting, this is the second Rittenhouse chime I've worked on. I did a video recently where I worked on a 8-note long tube mechanical Rittenhouse chime, and it had the clock motor and the contacts much like an old NuTone chime would have. And I noted in that one also, these pegs here, there's 4 of them. This is where the tubes hang. There would be a string hanger or something, and there's a groove here to hold it in place, but there's no adjustment. There's no way to move the tubes in and out closer to or further away from the plungers. So the volume adjustment gives you some control, but it's more preset in the way it's designed. So that's pretty much it. It's a 1991 Rittenhouse model C8846R, and it came in dead, and now it's going back out to the customer in working condition again. If you have one of these and you can't find anybody to repair it, I suppose you could contact me and I would talk to you about doing that. I hope you found this interesting, and maybe for someone it will be helpful. If it is, give it a thumbs up on YouTube, because that helps us just a little bit. And I noticed that people don't leave us a lot of thumbs up. Our videos get quite a few views. We do pretty well. I'm more than happy with that. But when you watch the video, right down below the video where you're watching it, where the title and stuff is on our YouTube page, there's a place where you can give it a thumbs up. And why does that matter? Well, it matters because the more thumbs up you get, the more the video is recommended for people to watch, and then more people find it, and maybe it'll help them with their problem. Giving it a thumbs up, all you gotta do is click on the thumbs up. That's all you gotta do. You don't have to leave a comment, just a thumbs up. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications, and every time we post a new video, you'll get a notification, and you can watch it. That's all for today. See you on the next video.